All right, we talked about how to solve a quadratic inequality algebraically. Let's talk about how to solve a quadratic inequality graphically by drawing it. Again, there are two general types of graphic or visual inequality problems. Type 1, which you've already talked about, is when you're comparing it to your y is greater than or less than or whatever equal to your quadratic. That's all of your x, y points which make the inequality true. And that's going to give you a region. It's going to give you a huge region in your graph. Your second type of problem is when you're comparing it to 0, when y is actually 0. And this is the case when you're only wanting what group of x values. And the problem that we solved in our last video was this kind of problem. But let's go ahead and take a look at problem number 1, type 1, when I do have like an actual y is going to be greater than or equal to some sort of parabola. Okay, how do you graph this thing? Well, here are some steps. Step number 1, you're going to find the vertex, and finding the vertex is at negative b over 2a. So you take a look at your b value and your a value, and that's going to give you your x coordinate. Then you can, once you figure out your x coordinate, you can plug it back into your parabola to figure out your y coordinate. So you find your vertex, find your roots, find your solutions. This is going to be the most important thing. And then you can create an xy table to find a couple other points here and there to kind of give you a general idea of what your parabola looks like. Once you have those key points, then you're going to draw just a rough graph. And remember, a dotted line means the points on your parabola are not included. Technically, it's a parabola, not a line, but you get it. So that's going to be like greater than, less than. A solid line, all the points on your parabola are included. So that's going to be greater than or equal to, less than or equal to. Okay, so this right here is just how to graph an actual parabola, an actual equation. But here, step 3 is where our inequality comes into play. We need to shade the correct area or the correct region. Now you have a choice. You can do these two. When y is less than or smaller than your parabola, you're going to shade below. When y is greater than or bigger than your parabola, you're going to shade above. Or your second option is you can just choose a test point. You can choose a test point anywhere on your graph, and then you can plug it back into your inequality. If it makes your inequality statement true, you would shade that area. If it makes it false, you don't shade that area, you shade the other one. So here's an example. I have the equation y equals x squared minus 1. Okay, so here's my parabola for x squared minus 1. Now, if I have the inequality y is greater than x squared minus 1, well, I'm looking for what x values are larger. Larger means, larger is up here, right? Going higher than this parabola. So I'm going to shade all of these x values. So all of the points inside here is going to make this statement true. So this point right here, 1, 2, if I plug the point 1, 2 into this inequality, it'll be true. If I plug this weird point up in here into this inequality, it'll be true. If I plug this point down here into the inequality, negative 2, negative 1, I plug it into that inequality, I will not get a true statement, which is why that is not shaded. Okay. You could, if you don't remember, do I shade above or do I shade below? Pick a test point. Ooh, 0, 0 is a great test point. Let's plug 0, 0 in. 0 squared minus 1. Let's see, 0 squared minus 1 is negative 1. Is 0 bigger than negative 1? Yes, it is. So because my test point lies in here and it makes the statement true, I would shade all of that in. Okay, here's another example. This is the parabola for the equation y equals x squared minus 7x plus 10. Now, my inequality is this. y is less than x squared minus 7x plus 10. Less than, not equal to, means I am not shading in all of that dotted line. And let's see, how am I going to figure this out? If I figure it out by a test point, I could still choose 0, 0. That's a nice one. If I plugged in 0 in for here, I would get, 0 squared minus 7 times 0 plus 10. Let's see, 0 minus 0 is 0, plus 10 is 10. Is 10 greater than 0? Yes, it is. Since my test point is here, outside of the parabola, I would shade all of this area outside. So all of these points over here is going to make this inequality a true statement. If I were to pick the test point 4, 3, just a random test point inside my parabola, if I were to plug it into here, I would get a non-true statement. So therefore, I would know that since that doesn't make the inequality true, none of these points will make the inequality true as well. So how to shade the correct region? You can either shade above or below, or you can pick a test point. Let's take a look at the second type of problem when we're comparing our parabola to 0. This is only going to give us x values that make the inequality true, because I already know what my y value is. My y value is 0. So this is kind of looking at our number line. It's going to be very similar to what we did before. Step 1, we can graph it, including our roots and solutions. We really want to know what our roots and our solutions are. Step 2, we're going to look at our x-axis, especially the roots. And we will actually see it break up into 3 main regions. We're going to see the x values that are inside the parabola, and then we're going to look at the x values that are outside the parabola, the ones that go to the left and the ones that go to the right. And we're going to take a look at those 3 regions, and we're going to say, okay, what x values end up having negative y values? Or alternatively, you could say which x values have positive y values. It kind of depends on what you're comparing, what your problem gives us. We're going to use that to see which of those regions I want to go with, depending on my problem is. For example, here's our example problem. What values of x will make the following inequality true? 0 is less than or equal to x squared minus x minus 6. Okay, well, let's see. This is not factored, so I would like to factor it so I could find the roots again because I'm comparing it to 0. So I'm going to factor this out to be 0 is less than or equal to x plus 2 and x minus 3. Great. My roots are x is negative 2 and x is positive 3. Those are my roots. So I can graph it like this. This is kind of my whole parabola. Or I can kind of think of it right here and just get rid of my y-axis and kind of graph it here, knowing it's going to go in between negative 2 and 3, right? It's crossing the x-axis at negative 2 and positive 3. And I really don't care. I know it's going to go up because I have a positive value here. So I really don't care where my vertex is. I could care less at this point. I just know my vertex is going to be in between here, right in the middle. But I just care that it's going in between here and here. Okay, so as you see, I graphed it. I have my roots. It's broken up into here's region 1 to the left, here's region 2 in the center, and here's region 3 to the right. Same thing over here. This is the same parabola, just a little more exact. Here's negative 2, here's positive 3, here's my vertex. Here's my region 1 to the left, region 2 in the center, region 3 to the right, okay? Okay, so that was kind of step 2. Step 3 is like, great, I want to use these regions, and I want to go, well, what region gives me a positive and a negative y value? Basically, I'm going, my negative values are below the line. So here, all of these would give me negative. Over here on this graph, all of these answers right here give me a negative. What gives me positive? Well, positive y values. Here's my positive y's. All of these above give me a positive. Same thing here. All of these above give me a positive. Okay, let's see. What is my problem asking me? When I want a solution that will be greater than or equal to 0, I'm looking for positive. Okay, so what values will give me a positive y value? Well, let's see. This is positive. So all of these will give me positive. This is positive. But all of these values give me negative. You see that right here? From 2, -1, 0, 1, 2, and 3 will give me a negative y value. Anything over here, -3, -4, -5, will give me a positive value. Same thing over here, it's the exact same picture. Anything from -2 to 3, I'm going to get a negative y value. Anything over here, I'm going to get a positive y value. Anything over here, I'm going to get a positive y value. Therefore, what I want, my solution, is going to be anything that is less than -2 or bigger than 3. And then there would be my notation value of it. And is it greater than or equal to? Yes, because 0 in my problem is A-OK. 0 is totally fine. I can get a 0. So that would mean those exact solutions are part of it as well. So that is how to take a look at a problem like this, where you're comparing it to 0. And it's a little more of a graphic explanation than the algebraic explanation, but they're both kind of taking a look at the same problem and solving them in 2 different ways.